So imagine you're tasked with wiring up a display in like a top secret government facility, and you're handed this single 33-foot video cable.
Right, just a normal looking cable.
Exactly. But then you look down at the invoice, and it is $315 for one cord.
Okay, let's unpack this because today you and I are doing a deep dive into a product spec sheet for the DVIGear DVI-2310 AOC-M. We really need to figure out why on earth a 10-meter DVI cable costs that much.
Yeah, it definitely causes some sticker shock, especially if you're just comparing it to, the bargain bin at a local electronics store.
Yeah.
But the secret is in the acronym at the end of that model number, which is AOC.
Right, active optical cable.
Exactly. So this really isn't your standard computer cord. You actually have two completely different transmission methods working together here.
And here's where it gets really interesting, right? Because it's a hybrid. I know standard cables just use regular copper wires, but what is actually going on under the jacket of this thing?
Well, it does pack 6 standard copper wires,
Yeah.
but the real heavy lifting is done by 4 polyfluorinated optical fibers. Wait, polyfluorinated?
Yeah, essentially they're a highly specialized plastic fiber. You know how traditional glass fibers for optics are incredibly fragile and brittle?
Oh, yeah, they snap super easily.
Right, so instead of glass, these fluorinated plastic fibers give you the massive data capacity of light, but with extreme flexibility and physical durability.
I love that. It's almost like building a high-speed bullet train out of light to carry your sensitive video data at lightning speed.
Mm-hmm.
And then meanwhile, you have a separate fleet of utility trucks, the copper wires driving on a road alongside it, just to power the train stations at either end.
That's actually a great way to put it.
Yeah, and because of this copper wires, the cable actually draws its power directly from the DVI source device. It uses, I think, less than 0.3 watts, so you don't need any clunky AC wall adapters to make the optical tech work.
What's fascinating here is how that hybrid approach solves a massive physics problem. If you send high-resolution video over standard copper, the electrical resistance causes signal attenuation.
Right, the signal literally degrades and just gets weaker over distance.
Exactly. But using light, it bypasses that electrical resistance completely.
Yeah.
I mean, this cable pushes data rates of 4.95 gigabits per second.
Wow.
Yeah. And it maintains flawless single link, 1920 by 1200 or 2048 by 1080 resolution. And it doesn't just do that at 10 meters. It can scale all the way up to 100 meters away without losing a single pixel.
Okay, wait, I have to push back on that a bit. 100 meters of cable is incredible, but if you're running wire that far, you are definitely pulling it through the walls of a building.
Oh, for sure.
And DVI connectors are famously massive. Like, they're these clunky plastic blocks with those super annoying screws on the sides.
Yeah, thumb screws.
Right. So how can anyone physically pull a giant plug like that through a narrow wall conduit without totally destroying those delicate optical fibers inside?
Well, this raises an important question about physical engineering. And DVIGear actually engineered a brilliant mechanical bypass. They use detachable DVI docking connectors.
Detachable, like you just take the end off.
You physically unclip and remove the massive DVI head from the cable right before you install it.
Wait, so how do the delicate fibers actually line back up when you put it back together?
They use a highly precise microconnector. When you pop that bulky head off, you're left with this tiny core measuring just 13.9 by 14.2 millimeters.
Oh, wow, that is extremely small.
Right. You pull that slim core through the wall using the included pull covers to protect the tip, of course, and then you just snap the DVI head back on. The internal housing forces those microscopic optical fibers into perfect alignment.
That is wild.
Plus, the cable itself is built like a tank. It can actually withstand over 500 newtons of crush resistance.
To put that in perspective for you, that means you could rest like a 110-pound weight directly on this tiny cable and it wouldn't crush.
Precisely. And because of those plastic optical fibers we mentioned earlier, it can safely bend to a tiny 2-millimeter radius without snapping.
Now, you might be thinking, I really don't need a crush-proof optical cable to hook up the old monitor in my basement. So what does this all mean for the people actually buying it?
Well, if we connect this to the bigger picture, extreme durability is really just a prerequisite for its actual target audience, which is mission-critical environments.
Like the military or government facilities?
Exactly, or medical fields. Because it transmits the video signal as light instead of electrical current, it has an incredibly low RFI and EMI profile.
Meaning radio frequency and electromagnetic interference.
Right. Standard copper cables kind of act like antennas. They leak electromagnetic noise.
And that's a bad thing in those places.
A very bad thing. In a strict security environment, someone with the right equipment could intercept that leaked electrical signal and literally reconstruct what's on your monitor.
That is terrifying.
It is. Or conversely, environmental electrical noise could disrupt your video feed. Light doesn't leak electrical signals, making it basically immune to that kind of surveillance and interference.
That makes the security aspect crystal clear, for sure.
On top of that, it is TAA compliant, meaning it's legally approved for United States government purchase, and it's plenum rated.
Plenum rate.
Yeah, so if a building catches fire, standard cable jackets can emit toxic smoke. A plenum-rated jacket is made of special fire-retardant materials designed for safe, hidden in-wall installation in commercial buildings.
It all makes sense now. So that $315 price tag isn't for, an everyday accessory. This is heavy-duty, highly secure infrastructure that's just hiding in plain sight.
It really is. It's the invisible backbone of a visual system that absolutely cannot fail.
Which really changes how you look at the world around you. The next time you see a flawless, high-resolution monitor in a highly secure government building or, say, a hospital operating room, ask yourself what invisible, lightspeed hybrid highways are silently working right behind the drywall.